Hi guys, in today's video we're going to be looking at a very simple chemical reaction. A chemical reaction that everyone pretty much is familiar with. But we're going to be putting a slight twist on it in order that we might not only teach about the reaction itself, but also teach a little something about solids, liquids and gases. Or gases specifically in this case, and also a little bit about density. So, the reaction itself is simply a reaction between vinegar, which is acetic acid predominantly, and sodium carbonate, bicarbonate of soda. When we mix them, we do get a chemical reaction. We can detect that by the fact that it effervesces, it fizzes. And these are the kind of signs of a chemical reaction that we'd be encouraging kids to look for in a primary setting. You know, change of colour, light being produced, heat being produced, or a significant temperature change, could be cold as well, and fizzing, the production of a gas of some sort are some of the clear indicators. So this one fizzes, and that fizzing is the production of a gas, and the gas in this case is carbon dioxide. Now, how can we prove that? If I'm teaching something like this, if I make an assertion, this gas is carbon dioxide, I like to find a way of demonstrating that to the kids. So one way we can demonstrate it is using one of the properties of carbon dioxide, and that's that it can put out a flame. It smothers a flame and blocks the oxygen from getting to it. The exact reason that it's often used in fire extinguishers. So carbon dioxide used in fire extinguishers because it puts out a flame. So I'm asserting to the class that the gas that's going to be produced in here is carbon dioxide. Their job is to prove it. I can give them, you can give them the materials. This one I would say is safe enough to do in a classroom setting. I wouldn't have any problem with this. If you're going to get the whole class doing it, they'll need a burning tray and they'll need a tea light. And they'll obviously need the reactants as well. Lighting a candle here, we can just leave that burning as long as they're all sensible enough. There's our candle. In principle, if this is carbon dioxide, we should be able to find a way of extinguishing that candle using the product of this reaction. So let's do the reaction first of all. So I'm going to trap this in here. Okay. Now carbon dioxide is relatively dense, not super dense. It will float away, but I can trap it in here. And because it has some density, I can also pour it. So once it's in here, which it should be now, the reaction is pretty much coming to an end. I should be able to pour this over the flame, and I'm oh no, not quite enough. I'm only pouring. I did actually pour a little bit of the liquid there. We'll try it again very quickly. Maybe use just a little bit more of each. There we go. Really go for it this time. Add a good bit more of each one. That's a bit better. And I'll pour it a little bit quicker this time. Oh, if it's not too fizzy. Give it a second. That's really fizzing up this time. I was maybe too cautious last time. And I should be able to pour this over, and there we go, the flame's out. And that was without pouring any liquid. So what I was pouring there was a gas, but because the gas has some density to it, it's able to flow downwards out and over the flame to extinguish it there. Okay? So I was a little bit too cautious with the volume that I used before. Better to use a little bit more than a little bit less. Cool experiment on its own. It's just a frivolous activity. But if you use it to teach a little bit about the reaction itself, and a little bit of making it a test, actually proving a hypothesis or proving an assertion, then it actually has some educational merit to it. So anytime an assertion is made in science, it needs to be tested. We should be maintaining a skeptical mindset and actually looking for a way of testing any assertions that are made. Cheers!